Hey everyone, welcome back. Before we blast off to explore one of the most terrifyingly beautiful and utterly alien worlds ever discovered, I'm sending out massive waves of positive vibes and heartfelt wishes to all of you watching. Seriously, wherever you are in the world, I genuinely hope you're feeling fantastic, taking amazing care of yourselves, and staying healthy. That's the most important foundation for enjoying the mind-blowing wonders of the cosmos. Now, buckle up tight, because we're leaving the cozy familiarity of our solar system and traveling 63 light-years away to a planet that sounds like it was ripped straight from the pages of the wildest science fiction novel. Forget gentle rain showers or even methane rain like on Titan. This place takes bad weather to a whole new, horrifying, and bizarrely stunning level. Meet HD 189733b, a planet where the skies aren't just stormy. They're a lethal, cobalt blue nightmare where it rains molten glass, sideways, at supersonic speeds. Yeah, you heard that right. Imagine standing on a world buffeted by winds faster than a bullet, drenched not in water, but in a searing hail of razor-sharp, liquefied rock, screaming horizontally across a landscape under the glare of a relentless, bloated sun. It's not fantasy. It's a confirmed exoplanet, and it's one of the most extreme environments we've ever identified in the universe. So, what exactly is HD 189733b? It belongs to a class of planets astronomers call hot Jupiters. Picture a planet roughly the size of Jupiter, our solar system's giant, but instead of orbiting far out in the cold depths, imagine it scorchingly close to its parent star. Much closer than Mercury is to our Sun. HD 189733b is one of these infernal giants. It whips around its star, HD 189733, in an orbit so tight it completes a full year in just 2.2 Earth days. Because it's so incredibly close, the star's gravity has likely locked the planet's rotation, meaning one side permanently faces the star, the scorching day side, while the other side is locked in eternal darkness, the night side. This proximity also means the planet is absolutely roasted. Daytime temperatures on the sun-facing side soar to a staggering 1,700 degrees Fahrenheit, around 930 degrees Celsius, hot enough to melt silver, zinc, and even some types of rock. This isn't just a warm summer day. It's a perpetual blast furnace. And that's just the start of the horror show. Despite being a gas giant like Jupiter, this extreme heat fundamentally alters its atmosphere, turning it into a churning cauldron of exotic, vaporized materials and unleashing weather phenomena that make Earth's worst hurricanes look like a gentle breeze. One of the most striking things about HD 189733b isn't just its violence, but its color. Thanks to the powerful Hubble Space Telescope, scientists were able to analyze the light filtering through the planet's atmosphere as it passed in front of its star, an event called a transit. What they discovered was astonishing. The planet appears a deep, uniform cobalt blue. At first glance, you might think of Earth's oceans, but this blue has nothing to do with water. On Earth, our blue skies come from Rayleigh scattering, sunlight bouncing off air molecules. Our blue oceans are because water absorbs red light. HD 189733b's blue is far more sinister. It's believed to come from a haze of tiny silicate particles suspended high in its atmosphere. Silicates are the minerals that make up most rocks here on Earth. Think sand, quartz, or glass. On this hellish world, the extreme heat on the day side vaporizes these silicate materials. The resulting tiny droplets or particles scatter blue light. Much like dust in Earth's atmosphere can make sunsets red, but on a planetary scale and with a different composition, resulting in that deep, ominous blue hue. So, the beautiful color is actually a sign of the planet's deadly nature. It's the glow of vaporized rock. Now, let's get to the truly mind-bending part, the glass rain. How does that work? It all boils down to the insane temperature differences and atmospheric dynamics driven by the planet's tidal locking. Remember, one side is perpetually facing the star, baking under unimaginable heat. The other side is in perpetual, freezing darkness. This extreme temperature contrast creates unimaginably powerful winds. We're not talking breezes or even Earth's strongest jet streams. Measurements suggest winds on HD 189733b howl at speeds exceeding 5,400 miles per hour, over 8,700 kilometers per hour. That's more than 7 times the speed of sound on Earth. These are supersonic winds screaming across the planet, trying desperately to redistribute the blistering heat from the day side to the frigid night side. Now, imagine the silicate vapors high up in the atmosphere on the day side. As these ferocious winds carry the vaporized rock material towards the cooler night side, the temperature plummets dramatically. Just like water vapor in Earth's atmosphere cools and condenses into liquid droplets when it rises and cools, the silicate vapor cools down rapidly. But instead of condensing into water, it condenses into liquid rock. Tiny droplets of molten silicate form. Essentially, it's raining molten glass. But here's the kicker that makes it even more terrifying: those supersonic winds. The rain isn't falling gently downwards like on Earth. Oh no. Those droplets of molten glass are caught in winds moving faster than a rifle bullet. So, they aren't falling. They're being blasted horizontally, sideways, across the sky and the landscape at hypersonic velocities. Imagine being caught in a sandblaster, but instead of sand, it's superheated, liquid glass shards propelled by winds that could shred steel. It's a relentless, horizontal sandblasting with molten rock. Any hypothetical surface features or structures wouldn't just be rained on, they'd be scoured, eroded, and vaporized by this sideways storm of glass. Even in the upper atmosphere, where the silicate haze forms the blue glow, particles are constantly condensing and being whipped around in this maelstrom. The rain might not reach a solid surface, as it's a gas giant, though it might have a molten core or exotic layers deep down, but this violent condensation and horizontal blasting dominate its upper atmospheric weather. You might wonder, how on Earth, or rather, how off Earth, do we know all this? We've never sent a probe there. It's far too distant. The magic lies in spectroscopy and incredibly precise observations, primarily from space telescopes like Hubble and Spitzer. When HD 189733b transits in front of its star, a tiny fraction of the star's light filters through the planet's atmosphere. Different gases and particles in the atmosphere absorb specific wavelengths, colors, of this starlight. By analyzing the resulting spectrum, the fingerprint of missing light, scientists can identify which molecules are present. This is how they detected the signatures of water vapor, methane, and, crucially, silicates in the atmosphere of HD 189733b. The detection of silicate vapor was the key clue pointing towards the potential for glass rain under the right temperature conditions. Furthermore, by observing the planet just before and after it passed behind its star, a secondary eclipse, telescopes could measure the tiny drop in total light, star plus planet, as the planet disappeared. This allowed scientists to directly measure the temperature of the planet's day side and even infer some atmospheric properties from its emitted heat signature. The combination of transit spectroscopy and eclipse measurements painted a picture of a scorching world with a silicate-rich atmosphere and extreme temperature gradients, the perfect recipe for the hypothesized sideways glass rain and supersonic winds. The blue color, measured during transit, was the visual confirmation of the silicate haze. HD 189733b isn't just a cosmic oddity, it's a crucial laboratory for understanding planetary atmospheres in extreme environments. Studying such a violent, exotic world pushes our models of atmospheric physics, chemistry, and dynamics to their limits. It shows us the incredible diversity of what's possible out there. Before we discovered exoplanets, our models were based solely on the planets in our own solar system. Hot Jupiters like this one forced us to completely rethink how planetary atmospheres behave under intense stellar radiation and tidal locking. The processes we infer on HD 189733b, vaporization of rock, supersonic winds transporting heat, condensation of exotic materials, might be happening, perhaps in slightly less extreme forms, on other hot, rocky worlds or gas giants close to their stars. Understanding the silicate cycle on this planet helps us interpret data from other exoplanets and refine our search for potentially habitable worlds. If a planet can have weather this extreme, it makes us appreciate the delicate balance that makes Earth so hospitable. Contemplating HD 189733b is a profound exercise in cosmic perspective. It shatters any notion that planets are serene, Earth-like orbs. It showcases the universe's capacity for creating environments of terrifying beauty and violence that defy our imagination. That deep cobalt blue, seen from afar, is mesmerizing. But up close, it's the harbinger of an unending, supersonic storm of molten glass. It's a world where the very rocks of the mountains we know are vaporized high in the sky, only to condense into deadly rain and be hurled sideways faster than sound by winds born from the eternal struggle between scorching day and freezing night. It's a reminder that the laws of physics and chemistry, so familiar and predictable here on Earth, can combine under different stellar influences to create realities far stranger than any fiction. HD 189733b stands as a testament to the raw power and diversity of the cosmos, a jewel blue hell cape where it rains glass sideways, forever screaming through an alien sky under the glare of a close, unforgiving sun. It's a humbling glimpse into the infinite possibilities of planetary creation, a masterpiece of cosmic extremes that challenges our understanding and fuels our awe. So, the next time you see a gentle rain shower or feel a strong wind, remember HD 189733b, our distant, terrifyingly beautiful neighbor, where the weather forecast is always the same: scorching heat, supersonic winds, and a lethal, sideways downpour of molten glass. Thanks for exploring this alien storm with me today. Stay curious, stay healthy, and keep looking up and appreciating Earth's gentle rain.